Okay, there we go. All right, welcome everybody. I'm going to be doing a quick software overview for the autonomous robotics course. The main sensor that's going to get featured here is the camera along with the BNO055 IMU. And the main thing I'm going to be showing is just how all of the different software components work when we put them all together. And I'll show a couple of them individually and everything like that. So let me share my screen on the Jetson Nano side. I'm sharing my screen. Let me just make sure that my camera gets set up correctly here. Just want to make sure this camera is always showing up here in the top, and then I'll minimize this right here. There's the minimize option, and let me hide that. And okay, so we're here on the Jetson Nano. Over on this side is just my camera from a different computer, but this is the Jetson Nano that's inside of our submarine. And I'm going to quickly open up a terminal, and hopefully it's not too laggy. But yeah, it looks like moving the mouse, it's not too far behind, not bad. Okay, so this is our main desktop, folder before the desktop. And this AI class workspace is my Catkin workspace where all of my raw stuff is going to be happening. Inside of here, you have your normal build, devel, install, and source. And all of our real code is going to be inside of the source folder. Let me take this earbud out. And then the autonomous robotics class is where all of my code is really going to be. So let me clear all of that and do this. So these are all of the packages and all of the different ROS codes that we're going to be running. So you have the computer vision package, the graphical user interface, the guidance navigation control, sensing and actuation, and the state machine packages. And inside of all of these, there's different codes. Each one has its own thing going on, and each one is a different node in your ROS network. So just to get started, just to make sure everything is working, I'll open up this state machine. So we'll change directory to the source of the state machine folder and do ls. And I'll run the perfect case state machine. So first of all, let's open up a new terminal and make sure ROS core is running. That should be good. And then I'll do Python perfect case state machine. And I'll open up another terminal and I'll do ROS run /viewer.py. So hopefully this doesn't take too long. The Nano is going to be running a lot of things, including sharing the screen. So hopefully it's 4 GB of RAM, won't be overrun too much. Yeah, looks like we're okay so far. So this is the perfect, like super perfect case state machine. There's only 6 states in here. You initialize the robot, so make sure all of the nodes are sending data. After that, you go down underwater and you search for the buoy. And then once you see the buoy, you move on to the center with buoy task. So you center with the buoy. Once that works, you bump into the buoy. And then once you complete that, you turn around and you search for the base. And then once you see the base, you surface and stop robot. And that's like the perfect case. Everything went correctly. Nothing went wrong. That state machine is working. So good to see that. I'll close this. I'll close all of that. And let me stop that. So let me go back to the main folder section here where all of the packages are. Next thing we can check out is this computer vision folder. So I'll just go into the computer vision folder, do ls, and we see this cvstart.py file. This is the file that's going to be running all of our computer vision. This might take a minute with the screen sharing, but hopefully this will be up in a few seconds here. Move this a little bit. Still running. And any second now. Oh, there we go. Okay. Usually it takes half as long, so not that bad. Our FPS is still 16, 15-ish, so that's not too bad. And if I wave my hand on my monitor here, it's still pretty smooth. On the Zoom call, though, it does look a bit choppy. So apologies for that, but it is smooth up here, so not too bad. So this is working. And then also I have my camera box that I have this trained to detect. So if I put that down right there, perfect. It's printing everything out. That's all good. The first one is the name of the object, so camera box. Then we have our confidence level. Right now it's only about 93%. If I move this closer, we hit 99%, perfect. 99.8% confidence that this is the object. Then my degrees, it's off in the X, and then Y and Z, these are in meters. So that's why those are a lot smaller than the X. But yeah, it looks like that's working. I can move this around and hasn't missed a frame yet. So that's perfect. Nice. Oh, missed one frame right there. Okay. So we know computer vision is working. So that's good. We know the state machine is working. Let's close that out. And then let me go back to our main folder here. So we know everything is working. We might as well just jump right into the launchers file. And this real launcher.bash is the file that's going to open up everything. It'll open up the computer vision, the state machine, the guidance and navigation, the GUI, and the sensing and actuation code. So all 5 of those is going to get opened by this. But before I do that, just for my sake, I just want to open up ROS topic echo task desired action. Tab autofill didn't work. Desired action. I just want to have this up in the side here, and you'll see why in a second. So yeah, let me do bash real launcher.bash. This will open everyone up. 1, 2, 3, 4, and 5 terminals. Okay. So now I might as well leave this open. I don't need this. This is our guidance and navigation. I don't need that. I don't need this information that's the Arduino and ROS serial communication. Camera is still opening up. And there we go. Camera should be open somewhere. Where is it at? There it is. Perfect. Okay. So our state machine right here. Oh, I didn't press enter. I wanted to show this, but it didn't work out. I didn't press enter in time. Whoops. Our state machine right here gave true, true, true. That means that the sensing and actuation, so the Arduino is sending data, the computer vision is sending data, and the sensing and actuation, computer vision, and our guidance and navigation is giving feedback. So everyone is sending data, everything is turned on. So that's good to see. And then it transitioned from the initialized robot to the search for Buoy State. So it perfectly transitioned everything. The initialized robot worked, and it moved on to the search for Buoy State. It went to dive, and it went to turn 45. And then it failed. And it failed because we waited too long. So it's given 30 seconds. So between here and here, you can see it went from 52 to about 84. So about 30 seconds. It had to complete that task, but it failed because we waited too long. So it moved to the surface state, and then it moved to the stop robot state. One thing I was going to mention, I didn't get to show it here, but the commands from the state machine down here in the bottom left, oh, the mouse is very laggy. I'll just highlight. The commands from the state machine in this bottom left terminal are going to show up right here in the top right terminal. So let me close everything and rerun it so that you guys can see. Whoops. This is the control escape one. That closed, and then the ones that I minimized. It's already starting to lag a little bit. Hopefully I can get through this before this Jetson Nano overheats. ROS core plus these two. Okay, good. So I want this running. And then I want to run bash. So let's open everybody back up real quick. And this time I won't pause. We don't need the ROS serial. We don't need to see what this is printing. State machine data is here. I'll move this data up here. This is our Arduino data. And then our camera is up and running. Perfect. So the first thing that it sent out was depth set point of 1. So at the moment, since it's in air, my depth and my distance aren't being counted. So all I should have to do for this is move that a bit to the right. You see my roll is at -11. So I need to raise this up to about there. And it should stabilize. Oh, failed. What happened? Let me fix this. So whenever it's sitting on its own, the roll right now is at -12. And that's because the wheel underneath this electronics rack isn't put in right now. So all I need to do is turn this guy over, leave him at about -5.2. That's fine. Let's also turn this so that he's at 0 instead of 359. Yeah, okay. So one important thing, I wanted this to be at -5. There we go. Okay. One important thing is that this state machine won't move on to the next next command until all of these degrees are within 5 degrees of the set point. So in this case, the set points were 0, 0, and 0. So we're expecting something between -5 and 5, -5 and 5, and -5 and 5. And if it remains within those 5 degrees of the set point for like 3 seconds, then it'll move on to the next command. So let me close these. Apologies for running this so many times, but I need to do it from the beginning. Close that off. Close this and close that. And I need to close this one as well. Perfect. Okay. So I can clear and ROS topic echo task desired action. Good to go. And bash real launcher.bash. Hopefully this is the last time we have to run this. Let's see, ROS serial Python node. That's set up. Perfect. Guidance and navigation. That's set up. Perfect. Computer vision already opened. Good. And then I'll leave this here and put this here. So it already got true on all 3 instantly, and it moved on to the dive state, which set points were 0, 0, and 0. And our roll is at -6. So all I should have to do is lift this robot up a little bit. And perfect. Now I moved on to the turn 45 one. So now my set point for my yaw is 45 degrees. So I'm going to have to turn the whole robot. Whoopsies. Moving the monitor with it. Whole robot. Now it's within 45, but my roll is off. There we go. All 3 are within 5 degrees. Perfect. Now I moved on to the forwards task. Now for the forwards one, it needs to see, it moves forward until it sees the buoy, which in this instance, the buoy is this camera box. So once it sees this camera box, perfect. Now it moved on to the next state, which you can see in the top left there is the center with Buoy State. So this is gonna run. See my yaw set point in the top right there is 15 degrees. So I'm just gonna move this over. Now my yaw set point is 0. Everyone is 0. Okay, right about there. No. As long as this camera doesn't go out of frame, I have as much time as I need here with the current programming that's set up. It's a bit difficult to hold correctly. I'm also holding this at the... Perfect. So we got it perfectly. Now the next task is the bump into buoy state. This is the instance where the robot just dead reckons and just goes forward and bumps into the buoy and just like smacks into it and then goes back. But now it's set up, I can finally let go of that. Now it's set up to turn on 180 degrees and go forwards all the way back until it sees the base. And I don't believe I have this set up as the base, right? No, I don't. So the base would be a different image. So it failed right there because it took too long. But if I had it trained for the base object, I would just show the base in front of it, just like that. And it would say, okay, I found the base, and it would move to the surface task. So yeah, that worked perfectly. That was the whole state machine. So it made sure all of the nodes were sending data. It went down 1 meter. Since I don't have this underwater, it just checks if the robot is stabilized. I'm going to turn this back this way. And it turned 45. We showed that it stabilized. It went forwards until it saw the buoy. Buoy was found, moved on to the center with buoy. We just had to get that image centered. It was taking a while to center there, so maybe I'll mess with the error values and say, okay, maybe if it's within 10 degrees, it's fine. Right now it's set up to 5 degrees and like 6 inches of error, so not much to handle there, or not much to work with, I mean. And yeah, bumped into buoy, dead reckoning, searching for base, and then it fails right here because I don't have the base object set up. So all of that worked perfectly nice. So that was our entire state machine, and that was the computer vision working with it, and the guidance and navigation, and the Arduino sending the data, and everything working together. So I can close all of this up, and I might as well stop all of this as well. Yeah, I think that's everything I was going to go over there. Yeah, I don't need to repeat anything. That's about it. Thanks for watching.